Welcome back. We are going through the Level 3 Calculus differentiation paper from 2018 in ZQA Externals, and we are up to question 3. So we're going to differentiate this expression, and that is going to require us to use the quotient rule. So if u is e to the 2x and v is x squared plus 1, then we differentiate the both of them, put it together in the quotient rule. Just like that. So we've got v du by dx minus u dv by dx, all divided by v squared. Then we have part 2, parametric equations. So we will differentiate each of these expressions here, and then dy by dx, putting them together in the chain rule, we get 10e to the 5t over 10e to the 2t, which just simplifies to e to the 5t over 2t, so that's e to the 5t minus 2t, just using our index laws, so that's e to the 3t. So when t is 0, which is what we're trying to do for the question there, find the gradient of the tangent to this curve. So what's the gradient at t equals 0? Dy by dx will be equal to e to the 0, which is just 1. So for part C, we have this graph going on, and we're finding the maximum possible area of the triangle that's inside it. So we need to figure out how we can work out the area of this triangle. So we need, obviously, area is half base times height. Now this distance here is going to be our base. So that distance there, well, from here to here will be whatever our x value is at that point. So this will be x. And it will be mirrored on the other side because it's all symmetrical. So our base will actually be 2x. Now the height of it, this height of the triangle here, that will be whatever the y value is at that point that we've worked out for here. So the y value is given by our function here. So the height will be 15 minus x squared. Let's just get rid of some of those scribbles. So we've got our height is 15 minus x squared, and our base is 2x. So the area will be equal to half times 2x times 15 minus x squared, which of course we can simplify to x 15 minus x squared, and that'll be 15x minus x cubed. I'm putting it in that form so we can differentiate it easily, because we want to find the maximum possible area. So I'm going to move down here now to be able to put it on the lines for writing. So we'll put our area equals what we just had up there, which was 15x minus x cubed. Now we want to differentiate that. So dA by dx is 15 minus 3x squared. Now we will find a maximum when that's equal to 0. So we then can work through what that would give us. So we can get 3x squared equals 15, x squared is 5, x is plus or minus root 5. So when x is root 5, and it doesn't matter if I take plus or minus, it's symmetrical around there. So x is root 5, then the area will be equal to this 15x minus x cubed, so 15 root 5 minus root 5 cubed, which gives us a final answer of, well, in surds it's 10 root 5, or if you work that out as a decimal, it's 22.36. Now, have we got any units of measurement? No, we don't, so it's just 22.36. All right, part D wants the equation of a tangent, and to do that we are going to need to know the gradient. So we've got a product rule happening here for the y, so we set u is equal to x squared, v is equal to ln x, and carry on with those, which gets us to this point here just by using the product rule. Okay, now we're finding the gradient where x equals e. So when x equals e, the gradient will be e plus 2e ln e. So that just, well, ln e is just 1, so that cancels out like that, and we just get 3e. The other thing we need to know is the y value when x is e, so we can put it into the equation of a straight line. So when x is e, we get e squared. I'm just looking at this function for y. So e squared ln e. So ln e is just 1, so y is e squared. So pop it into our equation for a line. So y minus y1 is mx minus x1, and continue that working through. So y1 was e squared, m is 3e, x1 is e. And just tidying it up like so. All right, question E, we are on to our last bit of excellence. So we have this shape happening here. We've got these wire bits in between, and we're trying to find the minimum value for the total length of that wire. So we need to be able to find a total length for all of this wire here. Now, this length is no problem. In the middle here we've got x, but this diagonal length, we need to work out how we can find the length of that. So we have this triangle happening here, and of course that length there is the hypotenuse of that triangle. So this length here will just be 5. It's half of the 10 that we've got across. But this length here, that will be 10 take away x, because of whatever x value is in the middle here. We've got the 10 is the whole length. If we take away x, then we'll get the pieces that are left, and then they are being evenly divided by 2. So if we call that one the d for the diagonal, then d squared will equal 5 squared plus 10 minus x over 2 squared. So we can follow that through to get this expression for d squared. Now, if we're wanting the total length, so the total length, let's call that L, that'll be x plus 4 lots of those d. So this value of x in the middle, and add on 4 of these diagonals. So this will be x plus 4 times the square root of, in fact, I'm going to, instead of doing that, I'll do a half bracket. So pop that into here, and then to the power of a half to make it be the square root. Now, if we're finding a minimum, then we want to do dl by dx. So if we differentiate that, we get 1 for the x, and then we need to differentiate this bracket using the chain rule, so that will be 2, 50 minus 5x plus 0.25x to the power of minus a half, times by the derivative of the inside, which is minus 5 plus 0.5x. Now to find a minimum, we set that equal to 0. So what we'll have here now is we've got this 2 minus 5 plus 0.5x stays on the top. This was to the power of minus a half, this other bit, so that can go on the bottom. So 0.25x to the half, and move the 1 over to the other side. So we get is equal to minus 1. And continues to solve that through. Then we'll square both sides and solve that quadratic. So we get these two answers, but of course x has to be less than 10 because of the dimensions that we have up above. So x has to equal 4.226. And what were our units? That was in centimeters. And there you go, all done. If you found this video helpful, please like and subscribe so others can find it too.